Hi everyone. For this video demonstration, I'll be working through this example of a map completion exercise, and we'll go from the map and also complete a cross-section. In this map, you can see we have some outcrops. We have 3 different map units, including this unit here, identified by the circles, a clear or blank unit, and we have a unit defined by these crosses. We also have 2 bedding measurements on the map, and with this information we now have enough to make our interpretation and complete the map. So the first thing we can see from this is the 2 bedding measurements are oriented with about the same strike. We can measure the strike. We have the north arrow there, and we can use our Douglas protractor to put the center of the Douglas protractor at the intersection between the strike line and the dip line. We orient the north of the protractor to north on the map, and using another straight edge, a ruler for example, we can align the ruler parallel to the strike line. And in this case, when we use the strike and dip, we're using the right-hand rule convention. So we have a strike line. We could go either toward 236 degrees, or we could go to 56 degrees. And which one do we go to? Following the right-hand rule convention of strike and dip, if we lay our right hand in the orientation of the symbol, our thumb points toward the strike. Our thumb points toward the strike direction, and the dip is followed by the rest of our hand. It's dipping down toward approximately the northwest direction, and the strike therefore is approximately toward the southwest direction, or 90 degrees to the dip. So the strike of this measurement is 236 degrees as we read off of the Douglas protractor. We have the dip symbol there, so we have this strike and dip. Of 236/34. Writing this down isn't necessary to complete the map, but just wanted to show you another example of how strike and dip measurements work from a slightly different perspective. Our strike and dip of this is approximately the same strike, and with some variation on the dip, just a 1 degree difference. There's nothing in this map data that indicates a folded or faulted environment, so we start with the simplest possible case. And here I'm inclined to think that it is a tilted sedimentary sequence that is all dipping following the same 2 bedding measurements toward the northwest. Based on that interpretation, we can start to interpret the rest of the map by extending the contacts and defining contacts and coloring in the interpreted units in the rest of the map. So we have a convenient outcrop that has a contact. This is an observed contact as identified by the solid line on the map. To extend this contact from this outcrop, I'm going to basically follow the strike line of the bedding measurements that we have And as I move away from the outcrop, the contact line is dashed. And as we move, because this is an inferred contact, not an observed contact, this inferred contact is of relatively high confidence because we're very close spatially to the observed contact in the outcrop. As we continue to extend our contact moving further away from the outcrop, our confidence in this data starts to reduce. And so we reflect that lower confidence in our interpretation by changing the dashed contact line to a dotted contact line. We also have a contact somewhere between the white unit and the crossed unit. We unfortunately don't have an observed contact. We're going to assume it's the same orientation as this contact up here, following these two bedding measurements. And we know it's going to be located somewhere between this outcrop and these two outcrops. So something like that. Without any additional information, I'm inclined to split the difference and draw the contact about halfway between those two units with respect to the strike orientation. Now, because we're fully interpreting this contact, and it's a fairly low confidence of where it is, this entire contact will be dotted. So now we have our two contacts dividing the 3 units that are present on our map, which is great, and we're nearly there. So now what we can do is fill in the geological map units in the area outside of the outcrops. Remember, if we were using colors, it would have the outcrops would be shaded with a darker shade of the color, and the surrounding area would be a much lighter shade. In this case, we can represent the outcrop versus surrounding area simply by the spacing between the symbols. Outside of the observed outcrops, we have a lower density of symbols. And we can do the same thing up here on this open circled unit. Great. And now we're done. So that is our map, and now we just need to complete the legend. With our interpretation that this is simply a sedimentary sequence that has been tilted, so it's dipping about 35 degrees toward approximately the northwest. The units that are older would be visible on ground surface toward the southeast of the map, and the younger units would be visible toward the northwest, if you can visualize the 3D nature of that dipping pattern. So that means our cross-hatched unit is oldest, and our circles unit is the youngest. There we go. All right, so now what if we want to draw a cross-section? The orientation of a cross-section line is perpendicular to the structural trend, so in this case perpendicular to bedding. We want to put the section line close to the most measurements and highest confidence contacts that we can. So let's see, we can probably put it just around here, and you can draw on the section line. Whoops. Draw on the section line while holding your ruler steady. In a formal map with an error like this on a strike line, I would white it out and redo it. So I'll just take a second to do that. There we go. All right, so we've got our section line of A to A prime, and now we need to go to our section. Since we're going to put our cross-section on a different piece of paper, we need to use just a scrap piece of paper to transfer the size or the length of the cross-section line to make sure it'll be the same length between the mat and the cross-section. So we just overlay a straight edge of paper and draw on the ticks for the ends of that cross-section line. We will also need to know within the section line where our contacts and our measurements are that are controlling our cross-section. So we have a contact here, so we'll put a little notch on the cross-section line, and our other contact is here. We also have the measurement, and if we transfer that along strike directly onto the cross-section line, that's where our diptych will be. We also have another bedding measurement here to transfer onto our section line. Once we have that information, we can put our map to the side, bring in a blank piece of paper, and using a ruler or the straight edge side of your Douglas protractor, trace on the cross-section line. We can also transfer our information of the contacts and the measurement locations. And now we have everything we need for the cross-section on the cross-section paper. This spot here on the cross-section line corresponds to this bedding measurement, which is dipping 34 degrees toward A. So we need to draw our diptych dipping 34 degrees toward A. So we center our Douglas protractor. If your pen doesn't fit through the hole in the Douglas protractor, switch to your pencil, and we go from 0 degrees toward, on the side toward A, 10, 20, 34, and put a little construction mark there. We then align the edge of the Douglas protractor between our 34 degree construction mark and the location of the measurement, and we draw our diptych in that 34 degree orientation. So you can see the diptych there. And similarly for this point on the cross-section line, it corresponds to this 35 degree bedding measurement. So we go through the same process. We have that center mark of where our measurement is located. We go from the A side, because it's dipping toward A, count down 10, 20, 30, 5 degrees. We put a little construction mark there, rotate our Douglas protractor to the correct orientation, and draw our diptych there. So now we work on extending our contacts between our map units from the cross-section line above and below ground surface. We will extend the contacts following the same orientation as the bedding measurements. Below ground surface, contacts are solid lines. And above ground surface, contacts are dashed lines. Okay, now we go back to our map. We have in this section the open circle unit, which is our youngest unit, which corresponds to this area of our cross section. The map unit in the center is blank, and the unit toward A prime is the crosses. So you can see now from our cross-section interpretation, the tilted bedding at about 35 degrees toward A, or in the map orientation toward northwest approximately. And it's quite clear now that the crossed unit is on the bottom of the sequence, or the oldest unit, followed by the blank unit, and on top we have the youngest unit of the open circles. This concludes the demonstration of completing this map and section. I encourage you to complete this example problem on your own with the base map provided on OnQ. Thanks.